Good morning. Myself Prabhakaran J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is impulse and step response analysis of first order system from the unit 2, that is time response analysis. From the subject name is linear control systems. Yeah, let I discuss. First, let us understand what a first order system is. First order system are simple yet powerful models used to represent many real world applications such as RC circuits and temperature control system. These systems have only one energy storage element, which make them easier to analyze. Even though they are simple, they help us understand the basic dynamic behavior that exist in more complex systems. Now, let I define two important concepts. First one is impulse response, and another one is steps response. These are fundamental tests used to study how a system behaves. First, impulse response. It is the output of a system when a very short and high input is applied, like a sudden shock. This helps us understand the inherent behavior of the system. Next, step response. It is the output when the system suddenly changes from 0 to constant value. This shows how the system reaches its steady state. An important point to remember is for first order systems, the impulse response is the derivative of the steps response. Also, we introduce a key parameter called time constant. This determines how fast and slow the system responds. To understand better, let us visualize these response. For impulse response, imagine giving a, sudden push to a system. The output rises quickly and then gradually decreases back to 0. For step response, think of switching on a device. The output start from the 0 and slowly increases until reaches a steady value. At time equal to tau, the system reaches about 63.2% of its value, of its final value. If tau is small, the system responds faster. If tau is large, the system responds slowly. This concept is very important in system design. Now, let me move to the mathematical modeling of first order systems. Using equations, we can represent system behavior and simulate it using software tool. Simulation help us visualize how the system respond to impulse and step input, making theoretically concept easier to understand. At this stage, we perform one small classroom activity. The puzzle question you can see on your screen. Your job is you have to find the value of question mark position. Next, we analyze the simulation result. We verify the following steps. First, visual inspection. Here, checking if the graph follows exponential behaviors. Second one is time constant check, verifying whether the time reaches 63.2% at time t equal to tau. Tau is nothing but the time constant. And third step is peak verification. Here, checking if impulse response peaks correctly at 1 by tau. And finally, parameter tuning, observing and how changing tau affect system response. These steps ensure that our theoretical understanding is correct. This slide shows a comparison of step response and impulse response. It clearly demonstrates how both responses behave differently in a first order system. Such visualization helps in a deeper understanding of system dynamics. Now we are in the quiz part, and let I check your understanding through a few of the question I will ask. The first question is, a first order system is characterized by which one is correct? The first option is two energy storage elements, second option is one energy storage element, and third option is infinite poles, and fourth option is oscillatory response. Which one is correct? Option B is correct. One energy storage element. This is the correct option. And second question is, the impulse response of a system is defined as. First option is a response to a sinusoidal input, and second option is response to a step input, and third option is response to a very short duration input, and fourth option is response to a ramp input. Which one is correct? Option C is correct option. Response to a very short duration input. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.